Hello Year 10. Today we are going to be factorising expressions, but before we do that, let's quickly revise the expanding and simplifying that we were doing last lesson. So in question 1a, we want to expand 2x minus 3 in brackets all squared. Now to do this with the short method, you want to times the 2x by itself. So 2x times 2x is 4x squared. Then you want to times the 2x with the minus 3 and double it. So 2x times minus 3 is minus 6, and minus 6 doubled is negative 12x. And then finally, you want to do the minus 3 times itself. Minus 3 times minus 3 is a positive 9. In question B, this is a normal FOIL expansion. So we do 4x times 2x, which makes 8x squared. 4x times 1 makes 4x. Then minus 3 times 2x is negative 6x. And negative 3 times 1 is negative 3. Then you can see that we have some like terms in the middle that we can collect up. So 8x squared stays first. 4x take away 6x is negative 2x, and then minus 3. Then for an interesting one at the end, we have multiple things to expand and then some collecting up to be done. So the first two brackets, we do a FOIL expansion. 1 times 2 is 2. 1 times 3x is a plus 3x. Then minus x times 2 is minus 2x. Minus x times 3x is minus 3x squared. Then we are going to do a binomial expansion where the minus 2x is going to times into that final bracket. So minus 2x times 3x is negative 6x squared. Then negative 2x times 3 is negative 6x. Okay, let's see if we have some like terms to collect. Starting with the highest power, which is the x squareds, we have minus 3x squared minus another 6x squared. That makes negative 9x squareds. Then with the x's, we have 3x, take away 2x, so that's 1x, take away 6x, makes negative 5x. And finally, the only thing that's left is the constant, which is the 2, so plus 2 on the end. So hopefully you remember that from our previous lesson. Let's now look at factorising, which means that we want to put things into brackets. So the most familiar type of factorising is the taking out of a common factor. So you might have two terms like this, and both of those terms can be divisible by 2. So the 2 comes out the front, and we divide and put the remaining parts inside the bracket. But there are many other types that we need to learn about as well. So there is a difference of two squares, grouping in pairs, monic quadratic trinomials, and non-monic quadratic trinomials. So we are going to look at the first 3 of those today, and then we'll spend some time on the final 2 a little bit later on. So let's go through the first type, taking out a common factor. That's in example number 1 here. So you can see in 1a we have 5m plus 20. Both of those terms can be divided by 5. So the 5 comes out the front as a common factor. Then I open the bracket and I divide each term. 5m divided by 5 makes just m. Then 20 divided by 5 makes a positive 4, close bracket. Looking at b, we have minus 4d take away 10. If both of the terms are negative, then we want to bring out the negative as a factor as well. From 4 and 10, we can divide both of those by 2. Then I'm going to open the bracket. Minus 4d divided by minus 2 will make a positive 2d. Minus 10 divided by minus 2, so the minus is out the front, 10 divided by 2 makes a positive 5, close the bracket. You can always check if you've done it correctly by expanding it back out in your head and seeing if you get what you originally started with. In part C, 30m squared plus 20m. The number factor is 10, but they both also have at least one m in them, so m can come out as a factor. Opening the bracket, 30m squared divided by 10m. 30 divided by 10 is 3. One of the m's has come out the front, but the second m will need to go inside the bracket. Then 20 divided by 10 is 2. The m has been taken out the front, so that's it, we close the bracket. In part D, it would be tempting to want to expand this, but remember that we are trying to factorize, which means we want a common factor. The two terms that we have, this is the first term and this is the second term. Each of those terms has the same bracket, x plus 2, in it. So the x plus 2 is the common factor. Bring the x plus 2 out the front. And then from the first term, we would, if we divided the x plus 2 away, we would have a 2 remaining. So in the next set of brackets, we're going to have a 2. From the second term, the x plus 2 bracket is out the front. So what remains is going to be the 3x. So plus 3x, close bracket. Question 2. This is moving on to the second type of factorising, which is using a difference of two squares. Now, for this to be a method that you can use, you will typically have two terms and they need to be subtracted. That's what the difference part means. Difference means to subtract. You are subtracting two terms. And there's usually a squared, at least one squared in there somewhere, because you want to be able to square root to factorise. So, starting with some of the easier type, a squared minus 16. So we want to, these are going to factorise into two big brackets like this. What you do is you square root the first term. So the square root of a squared is a, and you put an a at the beginning of each bracket. Then you square root the second term, which is 16. So the square root of 16 is 4. And you'll have a 4 at the end of each bracket. And one in between those things, one of them will be a plus and the other one will be a minus. And that's your difference of two squares. Again, you can expand it to check to see if you get back to the original question. Part B, doing the same method, I'm going to have two brackets ready. The square root of 9m squared is 3m at the beginning of each bracket. The square root of 4n squared is going to be 2n. One bracket will have a plus in it, the other will have a minus, and we're done. Question C. We're going to have our two big brackets. The square root of x squared is x. The square root of 8, unfortunately, is not very nice. We need to go into square root form. Square root of 8, square root of 8. One will be a plus, one will be a minus. Now, because I've had to go into surd form, I would like to simplify my surd. So the square root of 8 can be broken down to be 4 times 2. So square root of 4 times square root of 2. The square root of 4 is 2, so it becomes 2 root 2. So to have that factorised and also in simplest form, we would have x plus 2 root 2 and x minus 2 root 2. Part D. We still have something squared minus something else, so this is still a difference of two squares, even though there's already brackets in it. So some big brackets to start with. The square root of x minus 3 squared is x minus 3. So each bracket starts with x minus 3 out the front. Then the square root of 7, unfortunately, is a surd, so square root of 7. In between, one will be a plus and the other will be a minus. And that's it. That's all we can do. Question 3, the third type of factorising is by grouping in pairs. So you'll identify this by having 4 terms, and you want to factorize them 2 terms at a time. Usually we just do the first and the second one together and the third and the fourth one together. So if I just look at my first and second term, both of those terms have an m in them. So I'm going to bring the m out as a factor, which would leave n plus 3 to go inside. In the third and the fourth term, I can factorize out a positive 3, which would leave n plus 3. Now, assuming that I've done this correctly, the parts that are in the brackets should always end up the same, which means that the n plus 3 is a common factor, and I want to put the remaining parts in a second set of brackets. So from the first term, if n plus 3 is out the front, an m will go in the bracket. From the second term, the n plus 3 is at the front, so a plus 3 will go inside the bracket, and that is now completely factorized. Question B. Again, let's look at the first and second term first. I can factorize out of there a q. That would leave 10p take away 1. Now the third and the fourth term, I can factorize out a 2, but if I factorize only a 2 out, I would get a negative 10p, which is not quite right. So instead I want to factorize a negative 2 out, which means it will become a positive 10p and then a minus 1, so that my brackets are the same. Then the 10p take away 1 comes out the front as a common factor, and the bits from the front, the q take away 2, go into their own bracket. Question C. Now, normally we do the first and the second term together, but there is no common factor between 2ax and minus 9. So instead, we can pair them differently. I might choose to do the first term with the last term because they both have an x in them. So if I bring the x out as a common factor, I would get 2a plus 1. Then looking at the two middle ones, I could factorize out a negative 9. So negative 9 would give me 1 plus 2a, or if I switch that around, 2a plus 1 again, so that the brackets are the same. Then the 2a plus 1 is the common factor that comes out the front, and I will have x take away 9 going into its own bracket. Okay, so we've done each of the types. Let's look at a few of the trickier ones. Question 4. So this simply says completely factorize. It doesn't tell you which method to use. When I look at this question, I can see that I have something here in brackets squared minus something else. So I am tempted to do a difference of 2 squares. However, before I do that, there is also a common factor between those two terms. So I'm going to start there. 4 is the common factor. And if I bring 4 out of each term, I will have x take away 4 in brackets squared minus 48 divided by 4 is 12. Then I have made the inside those square brackets there just a little bit nicer, and now I can do my difference of 2 squares. So I'm going to have 2 big sets of brackets to do my difference of 2 squares. When I square root x minus 4 squared, I get x minus 4 at the start of each bracket. Then I square root 12 to get a root 12 at the end of each bracket. One will be a plus and one will be a minus. However, because I now have a surd in my question, I want to simplify the square root of 12. 12 is the same as 4 times 3. The square root of 4 is 2, so it is equal to 2 root 3 as a simplified surd. So my most simplified answer will be 4 bracket x minus 4 plus 2 root 3 and x minus 4 minus 2 root 3. Question 4. I can see that I have 4 terms in this expression here, so that makes me think of factorising in pairs. If I were to factorize the first two together, I would get x bracket x plus 7, and then the second ones, I would get a y, and then it would be 7 minus y. So there's already a problem there that doesn't make the same thing. So instead, I have to pair these up a little bit differently. What I'm going to do is I'm going to pair the middle two together. So that can bring out a common factor of 7 and get x plus y. And then the first and the fourth one together makes an x squared minus y squared. Now you're going to say, that's not the same yet, and of course it's not. But x squared minus y squared is a difference of two squares. So I can factorize that further to be 7x plus y, and then plus x minus y, x plus y, the difference of two squares. Then I have a common factor of x plus y, which I am going to bring out the front. So x plus y in a bracket, and then I'll open another bracket and put the leftovers inside. So I have 7 from the first one plus an x minus y from the second term. And that's my answer. Okay, on to the next page. Question 5. Factorize fully using surds when needed. Okay, so still the same kind of rules, but we may have fractions and surds and other messy things getting involved. So, x squared minus 9 over 16. We are subtracting two terms. We have a squared in there, so this is a difference of two squares. So it's going to factorize into two big brackets. Square root of x squared is x and x. Square root of 9 over 16, you square root the top to get a 3 and square root the bottom to get a 4. So it's 3 over 4. One will be positive 3 over 4, and the other will be negative 3 over 4. In question B, two terms, and again they're subtracted, but this time I think I can bring out a factor of 3 before I do the difference of two squares, because there's a 3 sitting in front of my x squared there. So let's factorize the 3 out. That will give x squared minus 162 divided by 3 is 54. Then I'm going to do my difference of two squares. The 3 is just going to sit out the front, and then I have my two big brackets. The square root of x squared is x and x. Square root of 54, unfortunately, is going to go into surd form. So plus square root of 54, and minus square root of 54. Now to simplify the surd. 54 is the same as 9 times 6. The square root of 9 is 3, so it's 3 root 6 as a simplified surd. So it would be 3 bracket x plus 3 root 6 and x minus 3 root 6. Question C. This is a difference of two squares again, because we have a term that we could square root minus something else squared. So two big brackets. Square root of 25 is 5 and 5. The square root of x plus 2 is x plus 2. One of them will be a plus, but if you need to put a minus in, that needs to be in front of all of the x plus 2, which means that minus will need to expand through. So for the first bracket, the 5 and the 2 can collect up to make 7, so I'll have x plus 7. In the second bracket, I'm going to expand the minus through to be 5 minus x minus 2, and then I can collect up the like terms. So that will give x plus 7, and then 5 take away 2 is 3, and then 3 minus x will make that final bracket. Okay, last question, D. This is also a difference of two squares, because we have something squared minus something else squared. So this is going to go into two very large brackets because there's lots of terms in here. So when I square root the first one, I have 4f plus 3j. That will be at the front of each bracket. Then, square rooting the second one, I will have a 2f minus 3j and a 2f minus 3j. Now again, like the last question, when I do the positive version, it's fine, all the symbols just stay the same. But when I do the negative one, I'm going to need to expand that minus through that second those last two terms. So let's simplify this down now. This first bracket, 4f plus 2f makes 6f. 3j minus 3j cancels out altogether, so the only thing I have from that first bracket is 6f. From the second bracket, I have 4f plus 3j minus 2f, and then the minus times the minus makes a plus 3j. Then collecting the like terms in that bracket, 4f minus 2f makes 2f, and 3j plus 3j makes 6j. So there is my factorized answer. All right, that's the end of our lesson on factorizing using common factor, difference of two squares, and factorizing in pairs. You now need to do exercise 5b.